next level, so you need to align with safety and compliances, obviously the quality also, right? So to start with a very small steps. So we thought, being a Phytech being a OEM of embedded motherboard and single boot computers, but why we are getting into this automation solution, right? So what we see is, when our partners produce more, the next level of technologies what we develop in our lab, what we develop in our factory, what we manufacture at as a OEM, basically it is used in an efficient way, or it is helped to boost the market. So there where we thought, like, instead of talking about only about the boards, only about the system and module, so we partnered with MSME, who is mobilizing the small manufacturers, and IASC, who is supporting us to skill the teams or the people around this automation. So to start with, in a very simple steps, so we thought of, let's start with these topics, right? So when I say factory environment monitoring, it's a very small parameters which can be monitored, and then depending on the type of factory, so whether you are a part manufacturing company, or you are a chemical manufacturing company, or you are a different food processing company, so depending on your company, you have a compliances, and then you have to maintain some environment. It's not only about the temperature or humidity, but also the various byproducts or the various hazardous components which might be part of the production process, right? So we have to monitor the environment. So we will see how a simple solution we will try to get into a bottom level, that like you are not afraid of saying that, like, hey, I want to do this automation, and then how big the investment would be, right? So OEM like Phytech, motherboard manufacturing company, I'm trying to bring you the core components inside it, and then getting you the confidence, saying that this can be done. Nowadays this can be done with a very small affordable investments, right? So we start with the factory monitoring, and then the main investment of any company is, or the assets is, machines and people, right? So here you take care about the people in your company and your assets as a machines in your company. So once you do this, then you start saying that, how can I save some money? And energy is a core part of any company, to save your, to save some of your money, right? Like, and not only the money, but it also slowly start aligning the processes, start aligning the dependencies. We will see how these things are inter or correlated. And finally, so we wanted to help with some tools which we have been using in Phytech, right? So a simple softwares which help you to achieve the process automation, and these are the open sources. So we want to help you with the same tools what we do use internally, and how do we do some process automation, people management, the business management, the manufacturing management, or the component, the stock management. So everything in one small open source tool, and the automation tool for the all these IoT or AIoT solutions we will try to explore, right? So we already talked talked on these major 4 blocks, the factory automation. So here my developers would show you the most internal parts, of the solutions what you are seeing over here. So the factory environment, so you would see that very small industrial grade hardwares, how they can be used, and then like how you can build a small factory environment or energy management or machine monitoring solutions, right? So the demos or the solutions which we show you is not the end solutions, but it could be the start point. So there where we thought to create a simple solution with a very affordable price so that you can start with, right? So before I go, so coming to the factory monitoring, so we have a sensor node and we have a gateway wherein which you can bring in different types of sensors. So when you essentially do any monitoring, so whether it is a factory monitoring or a machine monitoring, the core component is your sensors, right? So now the sensors here, when you see these all parameters, so these parameters are sensed by some sensors, and typically to categorize these sensors, so I would give a small mantra. So when you talk about the sensor is a device which will uh, change its electrical parameters depending on the physical parameters around it, right? So when you take a temperature sensor, right, the physical parameter is the temperature sensor, temperature, and then the change of temperature would build some resistance, the variation in the resistance. It's the simplest principle, right? So and then we measure that resistance in terms of voltage. So any sensor with its physical the change in the physical environment, it do produce some difference in its electrical parameter. So what we do as an electronics guys, we supply some voltage, right, and then we supply some power, and then we see the variation of that power, and then we measure. So there is a a core sensing material, followed by a power source, and followed by the measuring device, which is so called ADC, analog to digital converter, and then using these simple three steps, right? In this again there is a sampling and conditioning, and finally the ADC value are transmitted over a digital medium. But the core fundamental part is basically, so you need to find the simplest sensor. So this is the biggest part wherein which lot of automation stops. So now what kind of sensor to use, or like what is the cost of that sensor? So no worries, we will onboard many sensor partners, and there will be a dedicated sessions in future where we will explore the different industrial sensors for different automation. But to start with, today we are using some MEM sensors which are all integrated, whatever I have told, all within the single chip you get. So it do the sensing, it do the sampling, and it do the conditioning of the signal, then it do the conversion, and then it finally gives a digital interface, so called I2C or SPI or UART within a single chip, and then you get a ready made values of the measurement parameters what you really want, right? So here we we use sensor, integrated sensor from Boss. And then coming to this, right, the architecture, as I told, so you could have a multiple sensors installed around the factory, and then all the sensors are connected to the gateway, and then the gateway is connected to your internal system or a external system which is sitting in your cloud. So the MSME, one of the core problem of MSME, once again what we are trying to address over here is, most of the time the MSMEs are driven by a single person or like a couple of people driving the company now, and the systems around them do not allow to share the things even outside or to the partners who really want to do the automation. So here, to break that barrier, so what we are found a solution is, now you need not to send all your data of your company to the cloud. You can categorize the data which is critical or which is more proprietary to your business, keep in house, and then the data which does not harms your business and it's only helps you to do taking small decisions or monitoring the things, you can still push it to the cloud. So you can do 100% on-prem data server or a cloud server which we say, and then or else the same thing can be hosted on a cloud. So we give you a simple open source tool which is based on again a things board, but like it is been customized by our team, and then it can also be customized by your people. So because we help them to learn those things from the basics, right? So in this slide, for you to take away, so there are sensor components, and there is a gateway, and there is a cloud. So in most of our solution you will find these. So we have a FG28 based sensor node, but like since we are from embedded side, so we help you on any microcontroller based sensor node to design, whether it could be a condition monitoring or a machine monitoring or a environment monitoring basically. So we can help you to integrate or to make a smart sensor node which are like connected to the gateways. So today the gateway solution is available at a affordable price, right? Starting what if you ask me, starting from 15,000 rupees, there are gateways which can be collecting the data to the cloud and then collecting the data from the sensor nodes and sending it to the cloud. You will see the live demos end of the session, right? So same thing again, coming to the machine. So now when I say machine, there are a lot of puzzles. Now I had a 30 years old CNC machine, so how can I fetch the data? So there are two puzzles over here. One is a machines with latest interfaces which will already having a inbuilt sensors and give you the data, but on the other hand you have the sensors which need to be fitted, or external sensors need to be fitted on your old machine. And believe me, these are not the costly sensors as it would be have been in your mind since decades. So yes, earlier if you want to do automate something, the sensor itself will cost you 10,000 rupees or 50,000 rupees. Then you have to invest on a 1 lakh rupees software or a 5 lakh rupees software. No, so that era has gone. So the IoT has brought a tremendous changes on this system, right? Like as I was telling, so now the complete sensing has been put it in a single chip which are available to you in couple of dollars. So you say any parameter, you would find a sensing chip which would be in couple of dollars, not in hundreds of dollars. Hundreds of dollars is a solution, but like in couple of dollars you would find a sensing chip for any kind of sensing. So now here So as I was telling, so you have two ways to go. If you have a latest machine, so you have to identify the interface, which could be like RS485, RS232, Ethernet, or single twisted pair Ethernet, Profibus, EtherCAT. So like these kind of interfaces you have to get the data from your machine. Or else if you are going for a very old machine, so you can easily retrofit the sensors around it. And then as like human, when you have some problem, what do you do? So you check your temperature, you see how you are able to move, basically what's your how you sounds like, right? Okay, and then you also check visually whether I'm good or not. So these are the things, it applies to the machine also. Now can I sense a temperature of a machine, some temperature and humidity and pressure? Can I measure? Can I measure the vibration? So how much momentum? It should be a stable, right? Like, so it would, when a mechanical machine is running, yes, there is a vibration, but like there is a pattern of vibration when it is running good and when it is not running good, right? So now how can we monitor that parameters to really decide the machine is running good or bad? So similar way you can do the sound sound monitoring. And now AI is coming. So today AI definition is more on a graphic or the image processing. So still now you can get a lot of solution based on visual processing. But as an embedded guy, so visual processing, I put it in a last. I want to put a low cost sensors within or to the machine so that I can monitor it. Again, so these could be wired or wireless, and then those data can be transmitted to a gateway, and the edge computing comes over here. So we have the devices in which can act as an edge computing device. So the whole of the data transmitted from the sensor, so is going to a edge computing gateway, and all these, from that data you can derive all these applications, right? So predictive maintenance or health monitoring, or any kind of applications to manage or to maintain your machine, right? So so my so here you can see again the same. So temperature, our guys will give a very initial start kind of solutions wherein which you can use, but according to your industry you can keep changing. So for example, here you are seeing a PT100, which is the easiest available temperature sensor, but not for all the industries it might be valid. So according to the industry and application you can keep changing those sensors. So again, as I told, so end of the day, as a company owner or the plant manager, you have to you have to understand what KPIs you are achieving after deploying these automation, right? So how much time you have reduced, or how much productivity you have improved, basically what is the what is the maintenance, how much maintenance, how much money you have spent on the maintenance. And similarly, the less the early the failure detection is, you do the less damage, right? So that's how you increase the life of the machine also. So similarly, so for the energy management, again here you have one of the easiest part to start the automation, I would say, is the energy management system in your company, which will indirectly saves your money. So today, end of the month, you are paying a bill, and something if you are saving from that bill, you can recruit an automation engineer. So that's what the easiest comment I would say, basically. And to do this, So you have now smart energy meters, we have panel energy meters. You just need to know the architecture, how to install those, and then how to get the data from it and do the optimization. So again, over here you could see there would be a panel energy meters or smart energy meters. Okay, it can be again wired or wireless, whether it is a RS485 wired or a wireless technology we are promoting, which is a standard, international standard, open standard, which is Wison. Again, taking the data and transmitting the data to the cloud server, which could be 100% on-prem server of yours, so no data going outside your company, and non-critical data which you want to send. Also you can set up a parallel server, the server, and you are the key decision maker which data you want to send it to the cloud, or you don't want to send the data to the cloud anytime today, so that's fine, no problem. So you can have a on-prem server. So similarly for automation, yes, you have generated a lot of data from your all the solutions what we have so far discussed, but how to connect? So now, as I told, like you might be having a existing machines, existing SCADA system, existing a lot of other systems. So how to get these data and try to make results out of these data, right? So so here what we do, we try to help you with a simple open source tools called Udo and Thingsboard, wherein which you can bring the data, where you can correlate this data and then start developing your business solutions around it. So that's how we feel that like you can build a unified digital framework for your factory, and you need not to be a big company. You need not to be a very big company. You need not to have tens of automation engineers and tens of digital engineers. You can do with one or two resources at a very low cost, open using open source solutions. So there where we are connecting over here. So you would see a Thingsboard is one of such open source platform, and Udo is for your process automation is what we do suggest. So right, so this is what you know. So collect the data, try to use the data basically, and while using the data, saving the money, which is again doing the automation and optimization. And finally, when tomorrow when you have to use AI tools, I say that like you need to have your data, your production data, your people data, your machine data, your company data. You need to have your data. And if you are not generating the data for your business, so you would be in threat after a few years, because you would be using someone's brain to control your business. So it's your AI or it's others AI tools which you will use. So your AI tools you can use once you have data gathered in your own factory, in your own organization, and later on put all these data together. You can buy a brain, you can buy a AI brain, but then train with your data, train with your processes to make it your own AI. So that is one of the key thing. So now I would like to transfer my session. So I was talking more on the technical part. Before leaving, let me just quickly give you few things. Srini, by the time you can check with Brijesh sir is able to access. So this is the edge AI device which I was talking about, and then you can see the AI kits using which you can do image processing. So these are the processor modules which are available by us. So typically we give these processor modules to some of the automation product manufacturing companies, not for the end automation companies. So we are in between the companies who automate your companies and then the chip guys. So we take the chips, we make these modules, and using these modules the automation companies build their products, something like this. So this is what I was talking about, right? So now you have gateways which are available in and around, like you can start from 15,000 to 30-40,000, but like you have whole of your PLC in your home. So these are kind of custom PLCs which you can make, and then you can recruit a software engineer or electronics engineer, embedded engineer, who would do all the custom solutions. So whatever we showcase, so in another 15 minutes we will start the demo session after Brijesh session, right? So these are the ready available hardware. So these are the core hardwares inside the products, but like these are few ready gateways which can be easily programmed as a gateways, and then we can integrate multiple sensors, whether it is a wired or wireless, and then you can achieve the automation at a very low cost. Today, please put some number which you felt that like to do automate something I need this much money. So I would request, by the time Brijesh comes in, so I ask you basically, can you put in chat what one thing you want to automate in your company, and then how much you felt. Okay. Okay. Yeah, fine, fine. Okay, so Brijesher is finding some difficulties in joining, but like I think here someone is there from IASC. Okay. Fine. So Srini, just try to help IASC team. So this is what like I was explaining, right? Like, so the gateways, the ready available gateways, which will help you to connect to different IOs. So this can be also directly connected to your CNC machines, and then like any other machines which do provide a standard interfaces like Ethernet, CAN, RS485, and digital IOs, and just plug in the device. So today already it is used in a lot of automations basically, and then it's a very you can say budget friendly or pocket friendly device. So this is one of the hardware which you can see that like it have a on chip AI, and then it can do the automation, means like after automation your data or during, so you can do edge computing or edge AI using this device. So you could see a imaging kit, AI imaging kit basically, so which is not in lakhs of rupees basically. So in in and around 25-30,000 you get these kind of kits, and then like your by just employing one of your engineer you can start infusing the AI culture in your organization. Today you might be thinking why, but I would suggest you as a partner that like you need to be ready for tomorrow. Whether you are able to convince yourself or not, we have to automate, because the customers who would be coming to you would be deciding so what they want, and then to meet their expectations we have to do that. So so what here I will stop for some time, and then like maybe we can have some questions. By the time Chaman sir you can set up the demo, and then meanwhile if Brijesh sir can join in between.
Okay, sir.
Any questions, please? I want to automate temperature, humidity, fan, 20 analog, 20 digital input, and IO facility. Great. Gautam ji, great. So that's see the easiest architecture would be. So let me show you one of the architecture which we do use inside our factory. So typically what you can do this, sir, so depending on your devices, so we can have a multiple low level gateways, or the gateways which act as a protocol converters, and then we have a DIOs. So you have a very low cost DIOs which will be typically giving the data over Modbus. So couple of keywords which I want to leave with all of you is basically for do the automation. So always sensors, you always try to see whether it is a Modbus, RTU, yeah, people have, right? So one, this is the simplest one, and then you have a gateway, and then you have a on cloud server, right? So this would be the simplest form to achieve. Now for your multiple DIOs, yes, you can build all these processes. What I have shown is basically there are also a low cost processes you can do, but essentially if it has to be a wider inputs and outputs, that means more number of inputs and outputs you need, better you make it as a master slave architecture, something like this. So you could see uh, edge AI gateway over here, and then there are multiple gateways connected to the edge AI, because again here it is decision is the communication part, right? So whether you are using OPC UA for as I told, Profibus, Ethercat, Profinet, so these are the complex protocols which are used in bigger industries and bigger machines. But like you have a lower complex interfaces with the devices like your energy meter or with your different sensors, the digital input and digital output. So you can always go with a small Modbus RTU sensors, and then other devices which we have, so we can help you, and then we can do. And then yes, you can also make it wired or wireless, the sensors. uh, Sureshji, here like when you say Udo, I would more prefer the Udo for a process automation, and then Thingsboard we can do it for the sensor integration, but yes, nevertheless, you have a Postgres database, and then still you can use also your Odoo for the sensor data. So Sriram, so there are two levels of AI implementation. One AI implementation on the edge AI, and one AI implementation on your cloud. So you have a cloud server in which you can have the bigger database and bigger models running. But for your processes specific AI models can be built for an edge device, which could be of a one top or two tops of NPU processing capacity, and you can run the AI models in these edge gateways. Yeah, so these all Gautamji, you can put, so maybe like after the class we can discuss on the architecture. So we would be giving we can have a one-to-one session. So my team would help to build you at least one solution architecture for free. That would be a giveaway from this workshop. So not only this workshop, but like after this workshop we would like to interact with you and try to understand your problem and give you at least one level of architecture. How can you build the automation? So Raghavaji, how can we integrate new sensors in older machines? So as I told, these are called retrofit sensors, which will be wired or wireless, can be fixed to your machines, and then again the gateway and the cloud story or the same. This device, as I shown, this device, you take this one box can have multiple sensors connected through its different interfaces, and this one can act as a brain to convert your legacy machine to a intelligent machine. So you are adding a computer, you are adding a very low power computer to your machine to make it intelligent. How to do that? Like probably I need some of your inputs, and then like we will give you the architecture around it. Okay, so Chaman sir, you continue with this continue with the demo, and parallelly we will answer the questions through chat, and then again end of the session we will open the mic.
Sure, sir. Thank you, sir. Okay. So I hope I am audible and my screen is visible. Yeah. Yeah. So here basically we already, as Vasu sir told, we have a four different pen domain where we have energy management system and energy factory environment monitoring and machine monitoring system. So if you see here, right now we have different sensors node, but as a demo we will keep one sensor node and we have a gateway. So in this sensor node we have one panel meter and we have a Modbus relay, and we have our sensor node there. So that sensor node will get the data from both the panel meter, that is RS485 based. Once it will get the data, then we will over the voice of mesh network, it will send to our gateway, and then through MQTT we will send to our cloud. Okay? And that is our energy management system. So some parameters are there, and I will put that two protections is also there, and for that I will show you. And then factory environment monitoring, if you see, we have a different sensors that might be more than also. For right now, we get one sensor node, so that the BME 680, from that we will get the four parameter, and that we will send to the gateway, and then from there we will from the cloud we will get to see all the parameters. And then for machine monitoring system, basically we will simulate all these things right now. So that will be, if you will see, you will just think like a condition where we have a single phase 4 pole induction motor that will be running in the 1500 RPM. So now if some vibrate, so we what we will connect here, we will simulate it here is basically the temperature sensor, humidity sensor that will be connected to the analog input RTU. So from here we will get the data, and from digital RTU we will get the proximity sensor. From this we will get to know the speed of the motor. And from this, this is basically vibration sensor. From there, we will get the 4 parameter, that is velocity RMS. So, the guest is joining. So I will stop here. So once he will finish, then we will start with the demo. Thank you.
Rajesh sir, over to you. You can unmute.
Hello. Hello.
Yeah, you are
You're
audible,
audible.
sir.
Yes, sir, you are
Yeah,
audible,
yeah.
sir.
Yeah. Good afternoon. Yes, there was some technical issue, so I joined a little late. Okay, so that is fine. Okay. So good afternoon to everybody. I'm Brajesh Kumar. I'm CEO ISC Sector Skill Council. Okay. So I was having a discussion with Mr. Vasu, and we realized, like, industry in today's days, like, they have different problems, but some of the problems which are major problem areas, one is the technology aspect, and what all the technologies are required in the industry to advance their productivity, uh, to move towards a more digitalized factory. Okay. At the same time, another challenge, what we discussed, like, this is one of the major challenges. Even if the technology is there with the industry, who are the people who are going to actually adopt this technology to help in adopting this technology? So the skilling that way becomes very, very important for the industry. If you have the technology, you need people who can actually help you in adopting technology. If see, looking at government's perspective, now the government is hoping to make India the manufacturing hub in the world. And manufacturing can go to the next level only when we have advanced technology adopted by the industry, by MSME sector. So that way, we need the skilled manpower which are required by the industry, MSME as well, and the big industries as well. Okay. So to give that impetus to make an India movement of the government, the skilling is very, very important. And that is the reason our leadership in India, the Prime Minister Modi, he has given that kind of slogan, like, to make India the manufacturing hub. At the same time, he has also given the slogan, making India a skill capital of the world. Now, in this perspective, I would like to discuss why skilling is very, very important for the industry, how industry can skill their manpower, and how the workforce can be mobilized and awareness can be created among youth to get themselves skilled. Now, if you look at the engineering colleges in India, almost every year 15 lakhs of students do pass. But then the report says, like, the hardly 3 to 4% are getting the kind of job they are expected to. So there is a huge gap. There is a big gap between what the engineering colleges are teaching, or maybe what the students are learning in the college, at the same time, what the industry is required. Now, that is one aspect. Now, skilling I'm discussing in two dimensions. One is skilling for the students, for the youth, which are going to be employed by the industry. Now, that is one aspect. Another is now the current workforce in the industry. The current workforce in the industry also, they need to upgrade themselves. Technology is changing very fast. So the rate of change of technology is such that if anybody, like, if he is not updated, he is not upskilling themselves, like, so they will be outdated, like, so that is the reason upskilling is also very important for the people working in the industry. So the one dimension is a student, another dimension is the working professional. Now, talking about the student, the universities, the colleges, the most of the time, the what they are teaching in the syllabus, and the syllabus is not going to change frequently. The syllabus is going to remain the same, stream wise. And that is the reason the government introduced this skilling aspect in the education system. In new education policy 2020, the skilling is starting right from class 8th. So the students, the kids, right from the class 8th, they are exposed to doing the things by hand. So in that context, the skilling, the many engineering colleges also, they are now adopting skill courses. We as a council, I'll introduce what the council is and what we do. I represent IAC Sector Skill Council. IASC, these are the subsectors known as, like, instrumentation, industrial automation, surveillance, and communication. So the government constituted different sector skill councils to work with the industries in that particular sector, and then identify what kind of skills are required by the industry at large, which is for that particular sector, and then identify those gaps in the industry and how those skills can be created for the workforce working in the factory or the students which are going to be employed. So we identify those skills, we do the skill gap analysis, we identify what kind of skills are required by the industry. There we develop a skills program. Those skills program, there is a government committee, the committee approves those skills program, and once that is approved by the government, that becomes a universal, they provide some universal skill number to that particular skill program, and that can be adopted by any university, any colleges across India. To attract more and more students towards the skilling, the government has also introduced this, they have given a uh, credibility to these courses, like, so 30 hours in skilling is 1 credit. So suppose we have some program, a skilling program, any student doing 30 hours program and getting the certificate by the government, so they will be able to get 1 credit in their credit bank. Similarly, we also work with the industry. The industry professionals, we have many knowledge partners. FITEC is one of our knowledge partners. The kind of activities the FITEC is doing towards digitalization in creating a smart factory. So we have the training modules, we have the skilling modules. We try to create awareness among industry professionals. We try those professionals to upgrade themselves, upskill themselves. Now we act pan India. There are many partners, there are many knowledge partners. So we support industry in creating that kind of workforce, which is going to adopt a new technology, which is going to take industry to the next level. Now there are some apprehensions from the industry, like if we upskill, there could be, like, the people movement. But then look from the larger perspective. Now slowly, see, this will always happen. You cannot stop people from moving from uh, one opportunity to another opportunity. But at the same time, if you look at the larger perspective from the country's perspective, the slowly that these people are getting trained, these people are getting skilled, and they are actually becoming asset, country's asset, like, and ultimately, as a whole, these workforce are going to help to the industry to move to the next level. Unless until we have a skilled workforce, we are not going to adopt the technology. Even if we adopt the technology, to run those technology efficiently at the plant, this will be a very, very challenging task for the industry. So my submission is, uh, my appeal is like, the students, universities, colleges joining through this webinar, or maybe the industry professionals joining through this webinar, they must start thinking, they must try evaluating themselves, they must assess themselves what kind of skills they should learn, what kind of skills are going to take them to the industry, the kind of industry they want to go. Just academic probably will not help. You need to have some additional hands-on training, skill training. We as a council, we support the industry, we support the university, we support many training centers in adopting the skill programs. We support them in designing them content, curriculum, what kind of curriculum they should have on emerging technologies, so that they can take up such programs at their institutions. Uh, Now, I would also like to touch upon, mm, now the government time to time to encourage skilling, they come up with some kind of schemes also for the industry, and they provide incentive to the industry, how the industry can get attracted to like upskilling kind of activities in their company. Now the government has come up with the scheme like recognition of prior learning, that is called RPL. Now in this particular format, the companies, they can identify the people in their company, and they can work with the council to provide short training program to their people, uh, to upgrade their skill as per their need. And for that particular training program, the government has given the scheme, through council, the all the expenses will be borne by the government for that kind of training. So this is the kind of initiative the government is taking to promote the skilling. At the same time, for the students also, the government is providing fund. It's not available every time, but then yes, this kind of schemes keep on coming. We execute such programs where the government funding is available, where the students can enroll themselves, they can identify what kind of skill courses they want to do. There are centers, they can enroll themselves, and the funding will be provided by the government. Similarly, the council has also developed short training modules, say 30 hours, 45 hours, 60 hours module. So there are many universities which are adopting these modules as an elective to their students, offering as an electives to their students. So any student already continuing their regular curriculum in the college, parallelly he can enroll in this kind of training program in the college, and he can complete as many training programs he wants to and get the certificate. So that is going to give them the competitive advantage in when they go for the job to the industry. Okay. We are also, as a council, we have developed one program that is called Apprenticeship Embedded Degree Program. Now, this is a very unique program where the university is going to have 2 years, it's a 3 years program in collaboration with the industry and the council, where the 2 years will be in the university, and the 1 year the student will go to the factory, in any factory, like as an apprentice. So this is called Apprenticeship Embedded Degree Program. Uh, we have launched one program recently, this ADP in industrial automation. Okay, so uh, then another program is like, there are many industries, big industries. Now retaining the employee is a big challenge for the company. So what they are offering from the day one, like, when the employee joins the company, they offer the degree, diploma kind of certificate. If they work for 3 years, so every 6 months they will be evaluated, and one certificate will be given. And over a period, after completing 3 years of employment with the company, he will be awarded diploma. So that way, they are ensuring, the companies are ensuring the employee remains there for 3 years. So this kind of activities along with the council, many industries are doing. We would and particularly our sector, if you look at the industrial automation sector, we are relevant to almost all the sectors. It's a horizontal sector. Whether it is pharmaceutical, whether it is in automobile, whether it is electronics industry, whether it is power plant, automation is everywhere. So normally we work with all kind of industries, all sectors, and there is a huge scope of automation. The way we are moving towards digitalization, I think the next 2 decades is next 2-3 decades is going to belong to industrial automation. So my idea of addressing this webinar was, I just wanted to create awareness, to communicate the message. The skilling is very important for the industry as well as for the students. They should start looking at skilling not from the education perspective, just education perspective, skilling rather from getting some hands-on training to acquire some kind of hunar. So they should start looking from that perspective. And more you skill yourself, more you are going to make yourself more competitive, and you will be always in demand. That's what I wanted to communicate, and council is there to support, to help. I'll share later on along with my contact details and ISC Sector Skill Council. You can go to the website, and then any kind of query, we'll be happy to support you. I think that's it. I'm done. That's that much I just wanted to communicate. Mr. Vasu.
Thank you very much, sir. Thank you for kind support, and then I believe we can bring a lot of synergies and digital strategies to help our partners,
Yes.
of course, MSME and industry partners. Uh, and after this session also we will send you a lot of details, so probably we would be happy to be part of your digitalization partners basically. So Phytech, as again I am saying, so we might not be the direct partners, so we are more OEMs at a board level, software level and all, but end of the day I have a lot of companies working with us who are building end products to do these automations.
Right.
So expecting Atmanirbhar Bharat once again, and let's make a product nation company. Chaman, thank you once again, Brijesh sir. Thank you to IASC team. So we would explore more opportunities for automation, quick automations for small industries. And then Chaman, please carry on.
Yeah. Okay. Thank you.
Yeah.
Thank you.
Thank you.
Thank you, Brajesh sir. Thank you, Vasu sir.
Thank you.
Okay. Yeah. So this is our digital factory gateway dashboard, basically. So in the main dashboard, I put the alarm for energy management system and for factory environment monitoring system and machine monitoring system. So these alarm are based on the some parameters of energy management. Suppose the protection I am protecting my system from the source side. Let it be the supply voltage is greater than somewhat whatever the our apprentice work on, mostly on the 230 volt single phase. So if the voltage is greater than, I put here 270 volt, it will trigger an alarm and automatically it will shut down our all the appliances. So this is the one we can protect from the supply side. Same way, if the in my load side, whatever the prescribed power I am using, if it is more than that power, it will trigger the RPC from here, and it will again shut down all the loads. So from this, we will protect our all the appliances from the supply side, also from the load side. That is for energy management system. Similarly, for factory environment monitoring, Here we have some parameters. Suppose from BME 680, I will collect 4 parameter, that is uh, temperature, humidity, and then gas resistance, and okay. So these are the 4 parameter, and then from if the range is greater than somewhat critical value, it will generate an alarm, and then accordingly we will trigger the action. Similarly, for machine monitoring, already if you see they are generated 2 alarm. So that is the from vibration parameter, vibration sensor. They will get the value accordingly. They will generate the alarm. So let us discuss one by one all the dashboard systems. So first, if I go for the energy management system, we see here now here for the demo purpose, what we kept is this is if you see here, basically this is our one prototype for energy management system where we have I put here 8 loads, and this is one panel meter and followed by our gateway, and below this we have one Modbus RTU relay and FG28 for sensor node, and it will get the data from 8. Okay. So now if I want to, suppose I want to control the load, okay. So from here I can control the load also, and from here I can read the parameters also. So if I start reading electrical parameters, it will start reading. Okay. So now, so you see, if I want to connect, suppose load 1, okay, let me show you that also so that you can parallelly see this also. Okay. So load 1 connected. So if you see load 1 is connected over here, if I connect, suppose now load 3. So load 3 is connected, and similarly it is reading the value also right now. So if I go for load 6, so load 6 is connected. So all load 8s are there, but for demo I keep 4 different bulbs. And if I go here, load 8 connected. So here this is the load 8, it is connected. So, and you can parallelly connect and disconnect all the 8 loads also. So if I see here, I will disconnect all the 8 loads. I will put all loads are disconnected. And similarly, you can put all load connected. So all the loads are connected in a single sort. Now, if for right now, what I put from the, so if you see this is 34 watt it is reading and the current is 0.15 ampere. Now, if I put the load more than, suppose for right now for demo purpose I use 120 watt. If the voltage is greater than 120 watt, then what happen? It will automatically shut down all the loads. You see now if I put it here, now you see it will read the value. Once the value is more than 120 watt, it will just cut down all the loads. See now it will just trigger. It is more than 120 watt. It will automatically shut down all the loads. That is what for the EMS. So you can just configure this is you can just think like this as a single sensor node. Similarly, if you have more factory at different location, so that location you can put this one node and you can control the things and you can collect the data and you can send to the one gateway, and then we can from the dashboard you can monitor. So it's a one node. That's why it's one we are seeing here. If it is more node, you can in the energy management itself you can see all the different nodes. And now if I go for another factory environment monitoring, so here we have a BME 680. So from BME 680, we are reading the temperature and we are reading the humidity, we are reading the pressure in hectopascal, and we are reading the gas resistance in ohm. So this is, if you see the graph also, it is showing in right now is showing the 15-minute, and every 5 seconds it is showing. And here you can see the telemetry also. So right now 12:23, and today it will just give all these parameters. And from the sensor is BME 680, I'm collecting all the data. And now here, if you see in this factory environment, if the temperature is greater than 45 degree, it will trigger an alarm. Similarly, we can go for humidity. If it is greater than 75 degree, it will trigger an alarm. And for gas resistance, if it is less than 50,000, means resistance is less, means AQI is more. So more the AQI, it is good. It is not good. So the critical limit for the gas resistance is 50,000. If it is more than 150K, it is very good. That means if gas resistance is more than 150 kilo ohm, and then AQI is less, indirectly proportional. So this is what we can go with factory environment monitoring. And if you go here, okay, from here, if you see in our demo, we have this one. If you see the sensor node, it will collect the data. So this is what we're collecting the data, and it will send to the gateway. This gateway will collect the data from this one, and that what we are seeing over here. Now, if I go with the third one, that is machine monitoring system. Here, what we have is we have a temperature sensor, we have a humidity. So this what if you just think it like a single phase 4-pole induction motor, correct? So single phase 4-pole induction motor that will be working that will be the running speed is 1500 rpm, that is correct. So now we have to understand means when the motor is suppose something happen. So before that happening, before the binding is going to damage, some bearing is going to damage, we have to understand before itself so that we can do the cut off the motor from the load itself. So on and we can understand the some alarm it will generate. So predictive and maintenance would be there. So there are some parameters. So if you see this temperature and humidity, we will keep this temperature near to the motor binding so that we can get the binding temperature and humidity. And this is connected to our Modbus analog RTU. Here right now, I will keep it here. This one. This one is Modbus analog RTU, and here we have a PT100 temperature sensor, and then it will send the data to this one. And from here, we will collect the data, and it is coming over here. Now, once we get the temperature, so for motor, if I say the value will be temperature value will be greater than 85 degrees, then might be the condition for temperature. So that's why I am putting here red color. So this is the warning. If it is more than that one, it will generate an alarm and automatically shut down the motor. And this is simulated values that and then from 33 to 66, it is the healthy condition, and from this one to 85, it is the warning alarm condition. Similarly, you can go for humidity. Humidity if it's more than 75%, it will be an alarm. So it's why it will show in the red color. Now, if you want to read the motor speed, so for that we will put the proximity sensor that will be connected to the digital digital input RTU. So that digital input RTU will get the data from the proximity sensor over the RS485, and then it will collect the data from the your FG28, and then from that proximity sensor, we will calculate the speed. So whatever the speed you are seeing, this is we are collecting from the proximity sensor. So these are the, if it is, see, ideal speed is should be greater than, if it is 1500, 1450 and 1550, it's correct. That will be okay, no problem. But if it is less than, if it is less than 1350 something, then it will be critical. It will be damaged position. So that's why I put it in the red color, and this is the alarm warning conditions. And if you see here, these are the vibration sensor that we will put, and we will collect all these 4 values from the motor. So this, if you see the vibration sensor, it will give the oscillation RMS. So I am just plotting the data also over here. So oscillation RMS, it will give how violently the motor vibrates. So if you see means how violently means we can just understand the vibrations of the motor. So that is one parameter. And if this oscillation RMS, if I say it is greater than 1G, then it will be a critical limit. Then it will trigger an alarm. So 1G means meter per second square. That is oscillation due to gravity. And then next parameter is our crest factor. So crest factor, if you try to understand, it is a ratio of a peak value to the RMS value, and it is also with respect to vibration only, and the limit for this one is 5. If the crest factor is greater than 5, then also it will trigger an alarm. Then this velocity RMS, this also derived from the oscillation RMS, and it is in the stated by the ISO 10816, and it is basically related to the mechanical stress, and it will trigger the rotor imbalance, shaft misalignment, and mechanical looseness, if you see. So that is all we will get from the velocity RMS. So the critical value for the velocity RMS is 4.5. If the value is greater than 4.5, it will again trigger an alarm and will stop the motor, and you can just do any automation over there by getting the value. Then the last parameter is the kurtosis. The kurtosis, it detects the bearing mechanism, means the bearing defects, if I say. So what is the before the bearing is going to damage, it will just give us the peakness of the vibration signals. So for bearing, if kurtosis, if I say, if it is greater than 7, then it will trigger an alarm. So that is all we can see the condition of single phase 4-pole induction motor, and accordingly it will trigger an alarm. And here we see the telemetry for this also. All the things we so right now in 12:30 we are at this date, we are getting all these parameters: oscillation RMS, risk factor, humidity, kurtosis, RPM, temperature, and velocity RMS. So I think that is all about the demo from my side, and this is what we have this one. Okay. This is all we explained from this poster also. Means this is the analog input RTU, and then here we have a PT100, and then some humidity sensor that will gate and proximity sensor, and then for vibration we have this sensor. It will read the data and then it will coming over here. Then from our dashboard we can get it over here. So here we see this alarm is also generated when is high power consumption, when the power is greater than prescribed value. So for high voltage, I cannot give right now in this environment greater than 270 volt. If we can give, it will generate the high power, high supply side voltage and also. So that is all from my side, Srini. Thank you all.
Hey, thank you, Chaman sir. I believe it has been a great real-time demo, although it is a bench setups. So the basic intention to share here is basically using a very small cost-effective hardwares and writing softwares. You can bring down the automation jargon to a smaller achievable goal. I believe my team has tried most of the information, but it do not stops here in this 1.5 hour webinar. We would love to hear from you guys. So there would be a feedback session where you please put up your requirement, and one-to-one basis our team would be discussing with you, discussing the problem statement, and till the architectural levels design support we will be providing it free, so that you can get it implemented either by Phytech or by your own team or by any other partner of Phytech or any open partner. So it's okay, but like for us it was more important to address the crowd and then raise the flag saying that, like, guys, we are in a critical stage of transition. And then today earlier automation was an option, but today automation is a need. And as I told, as a core IT tech guy, if you ask me, how can I prepare? Start investing very small, but with a motto or with a target of generating your own data. Generating your own data. So as I told, you can use Thingsboard and Odoo. So we can provide you a dedicated session. You bring up the problem statement, and our team will be able to support you how to realize it. Now, whether you want to do it by yourself or with Phytech team support or with Phytech partner support, as we have multiple partners developing these kind of end products. We are OEMs. We go inside a product. We are not a product manufacturers, end product manufacturers, but like we are inside those products which are getting manufactured for these devices.
I got a question here. Is there any sandbox provided for Rodo and other application?
Yeah, we can help you on that, sir.
Oh, okay, thanks. Thank you so much.
So one of the participant has asked Vipin, how can we implement this with AI in medical devices? So uh, when you say AI, it is a very big range, and then many times we get lost. What is that can fit into my device, right? So for here, I want to give a small guidelines. So when you want to automate, means make a device intelligent today, so we are transitioning from a legacy product to a digital product to a smart product to a intelligent product. Legacy product, which is a classical mechanical or any other device, to a digital product, which is an electronics based smart product which got connected, and next to smart is basically intelligent product which in wherein which the product have a AI capability. So now when we do this, so now the question is what big AI is needed, right? So the big AI, in order to categorize, you have 0 to 1 top, below 1 top. Tops like your processor speed you do, right? So below 1 tops is your MCU is based on MCU. 1 to 10 tops is embedded MPUs plus NPUs, and above 100 is what your above 100 tops is all your NVIDIA like AIs. So the cloud AI and other things, right? So at least this would be a benchmarks for you guys to really understand how. So all your mobile phones today, you have a AI co-processors which are like in a range of 1 to 10 tops. So you need to understand how which to implement and how to implement. We would be happy to have a dedicated session, brainstorming session, to help you or team to how your device can integrate a AI into the in your device.
How many tops is the maximum you are offering currently on your boards?
So typically on our we have multiple. It's not a single. So you have AM68 which can go up to 6 to 8 tops, IMX93 which will be again around 1 to 2 tops, IMX 8M plus which is 2.3 tops. So there are different variants, and then like the beautiful part of it is basically, for example, IMX 8M plus also provides a PCI interface wherein which you can add a NPU cards, additional NPU cards. Helio is, I think, Helio and like NXP has now acquired Kinara
Okay.
AI co-processors. So those can also be included. And the best part for our systems is, since we are a Linux and Linux expertise, so we can easily integrate those subsystems into our these SBCs.
Okay.
So if we have missed, so we have a Jairamji, any gateway device ready available for BLE mesh network? Yes, we have our standard gateways, and then we do support multiple BLE modules, mainly for Scilab, NXP, and other vendors like your even Nordic and all. So depending on your BLE sensor devices, we can support you to identify a good the gateway would be common, so we need to add a sync device, a sync device. So what security features are incorporated in the gateway? So there are multiple layers of security. So starting from the secure boot till the data encryption and secure communication, trust of chain from device till your cloud to the app is there. So we can help you guys to understand that architecture and implement the same. So I believe if any questions are missed, we will take it even after the session. So you guys have our numbers in the and then mail IDs are very simple: sales@fitech.in. Mine is vasu.b@fitech.in. Uh, arun.k@fitech.in. You have all these guys who are responsible to support you at Fitech from a business perspective. So the last but not the least, we would like to uh, announce one free MDP program which has been supported by MSME TC Bangalore. So we have a 5 days training program for working professionals who would like to do the automation. The only need is we have to identify a location, a hosting location, so where our team can come and then host a 5 days dedicated session for management development program. Under management development program, we are taking the automation, digital factory and automation, and then there are multiple other topics. So you can register. We will be sharing the link, and then we will be uh, asking you, so while registering, put up your problem so that those topics can be uh, addressed. So we are very um, extensively working with Government of India, and then MSME from each state is supporting us a lot. And then, as you know, we have been in this industry since last 13 plus years, but many of you guys might know me more than 20 years and above. Okay, so we are making a continuous efforts to bring India as a product nation, and then until and unless we are buying from we build our solutions in house rather buying it from outsource. Today we just try to if you really see, many of the automation devices are bought from outside. So very simple requirement recently we solved for a fire alarming system, using alarming sensors and alarming systems basically. So what we need is um, we need the problem statements from the partners, and then we will try to find out a supporting partners from government and other stakeholders basically. So Codicia is one of the active group in Coimbatore who are helping us in reaching us MSMEs in Coimbatore, and then MSME Vishakhapatnam is helping us to reach those local companies and address their issues. So we are trying to educate as far as possible, and then with all our together efforts and collaborative efforts, I believe we see a great future of India building together. Thank you all, and then request to fill the feedback. Maybe I don't know if the mics would be still open, but like if anyone want to speak, maybe 1 or 2 minutes, and then we close the session. It's already 12:45. Once again, thank you
Uh,
all.
Also, this
Yes, sir.
DGM MSME was speaking.
Namaste,
Can you hear?
namaste, DGM sir.
Namaste, namaste, namaste. I just joined about 5-10 minutes back. It
Yeah,
was a fantastic insight of the automation.
yeah,
As far as our support is concerned for conducting this MDP, we are all in, and you can basically we have our venue ready, and we can do it in our main tech campus here in Devnalli, or else even if you want inside the city in Rajaji Nagar, you please let us know. We have a city place where we can arrange for about 20-25 guys in the this
great.
thing, at least 30 people.
Yeah,
So venue is not a problem. You just get the people registered, and we can go ahead and do the session. Okay.
great, great, sir. Thank you for the
The
extended
similar,
support.
Okay. Thank
similarly
you.
in Mumbai, I have an office where 10-15 people can sit at Dadar East. It is next to the station at Dadar East. So very
Great,
centrally
great.
located. Anybody can come from Bombay, even outside Bombay,
Yeah,
for the training. And do
thank
ask
you.
your people to contact me. I put my number in the chat.
Yeah, yeah, Gautam sir. Sure,
Thank you.
that's great. So we would also try to pull in a lot of sensor partners. That would be a key role. So here we are more a digital guys, where we make the digital controllers, communication technology, processing units, and all. But today I believe we are lagging with the sensor manufacturers. So from this group, if they have some friends or partners who do the sensors business, basically, so they can also be part of this ecosystem, and then let's try to achieve at least some small success stories together. Thank you one and all, and then have a nice weekend.
Yeah, thank you, Vasu sir. Thank you, Brajesh sir. As we are
Thank you.
wrapping up today's session, I want to thank each and everyone for your time and participation. Your inputs is incredibly important to us, so we just shared a link in a chat box, and also we'll be sharing to your registered email ID and WhatsApp. You can share your valuable inputs there, and also we added our LinkedIn and YouTube channel links there in the chat. Okay, to get connected and continue learning and get latest updates, our upcoming webinars and products. Please do follow us and connect. Yeah. Thank you,
Sure.
everyone.
Thank you.
Thank
Thank
you
you
so
all.
much. Still, this chat will be in live. You can share your queries there.